When going into a new programming language, it is of course customary to start with primitive, simple types. So I'll just skip the long talk and dive head first. Primitive types are value types, which means they are almost always allocated on the stack. As a result, they are very fast and easier to work with. In C Sharp, we can divide primitive types into four categories, and here they are. We have the integer types here, we have the floating point types, character types, and Boolean types. Under the integer types, we have the signed and unsigned. Under signed, we have sbyte, short, integer, and long. Under unsigned, we have bytes, ushort, uint, and ulong. Now, long and ulong, they have both the same allocation, the same memory size. The difference between the signed and the unsigned is that the unsigned are always start from 0 to a positive number. You cannot have a negative number. And signed, you can have negative to positive numbers. So let's just go ahead and jump in. Integers are exactly what they sound like, whole numbers. They can be divided into, well, I already talked about that, signed and unsigned. So let's start with S bytes. S bytes. By the way, hang on. It is very important to remember that 8 bits equals 1 byte. This is a very important thing when dealing with types in programming. And this right here, this is not a C sharp thing, it's a programming thing. All programming languages adhere to this. And it's not because that's the way computers are actually designed. So, S bytes hold 8 bits. S bytes hold 8 bits. And they go from negative 128. Yeah, let me do this. Give me a second. They go from negative 128 all the way to positive 127. They are rarely used. So if you say 127, that's legal, and you can do this. And you can say small number here. And let's actually run this. You say .NET build. Why is this taking so long? Okay, 7 seconds. Anyways, .NET run, and you see 127. All we just did is we take this number and we print it out to the console. If we put 128, for example, you see it immediately tells us, let's hover over the constant value 128 cannot be converted to an S byte because this is above 127. So let's go ahead and let's actually try to build it. It's not even going to build. And here, you need to understand, failed with one error. Constant value cannot be converted to S bytes because once you go to 128, then you're no longer talking about S bytes. It is above the allocation. As a result, S bytes are rarely used. You can only use them for compact value, compact storage in constrained scenarios. Because it's so small, I mean, what are you even going to do with this, to be honest? Unless you should never you should only use it in the internal workings of your application when you need to calculate very simple small things. Next up, we have short. So let's call this moderate number. And short, which is 16 bits. Short is 16 bits. Okay? And can hold between negative 32,768 all the way to positive 32,767. Don't memorize any of this. Okay, just don't memorize any of it. Okay, you should only use it in low level protocols or memory sensitive arrays. Okay, so if you go anywhere above this, so you say 32,768, it's gonna throw an error as well. And so shorts, S bytes, and shorts are not widely used, as you can see. Okay, int, however, the next, what we're gonna talk about next, S byte and short are not widely used. Integers int, which stands for integer, is the most widely used type when users are working on an application. It is the default choice for integers. Like S byte, both S byte and short are both integers, but when you say int over here, this is the default type. Okay? This is what people use the most. If you, in fact, how do we know it's the default choice? If we change this to the keyword var, if we use the var keyword and hover over this, we can see it says int, local variable int number. The compiler will interpret your inputs as an int by default. Okay, int is a 32-bit, and since 8 bits 1 byte, so 32 is what? Well, we divide it by 8, so that's 4 bytes. So saying this int 5,000, or let's just make it 500. This is the same thing when, in fact, when you run this application, the computer, the compiler, C# compiler, will replace it with int system.int 32 number 500. Sorry. 500. This is the same thing as this. Both of these are the same. Integers int 32 can hold between negative, let's use a comment, negative 2.1 billion all the way to positive 2.1 billion. Remember, int is the default. I don't think it's just C sharp though. I think it's all programming languages, or most. I'm not going to pretend to know everything about other programming languages. Next up, finally, unsigned, we have the long. So we've talked about sbyte, short, ints. Finally, we have long. And long is the largest signed integer type, holding let's see, sorry, long called big number. So let's say 5 million. What the hell is going on with me? 5 million. Okay. So he holds the biggest numbers. I think it's like 4 billion. Huh? We can actually Google it. I don't memorize all this. Max value. Oh, wow. Oh, yeah, and it is 64 bits. So that's double integers, and it could hold, what is that, 9 trillion? Incredible. As much as 9 trillion. Anyways, just remember don't try to memorize all these numbers. These are just important things to keep in mind when learning the C sharp or any programming language. Next up, let's talk about unsigned. So we're done with this. Let's talk about unsigned. Bytes. Byte is just like sbyte, is also 8-bit. So that's just 1 byte. So we say bytes equals small. So you say positive small number 0, and you can say bytes positive small number 2. Oh wow. And we can say all the way to 255. And these are both valid. So let's say .NET run, and let's see what, in this case 0 and 255, it compiles without any problem. It can hold, you can use bytes mostly for like binary data and file input and output, as well as network protocols. Don't go over 2.250. Anyways, it's gonna warn you anyways. And if we try to run it, it's gonna scream. It's gonna scream at us. So next up, we have ushort. Ushort let's call it, can go from 0 all the way to, I think it's 65 thousand, something like that. Anyways, you can use it for like pixel values, and I don't know. I don't know else what else you would use it for. Next up is uint, and it's like integer but only positive as well. Remember, these are the unsigned. Unsigned means they can only ever be positive numbers. So it goes from 0 to, I think, 4.2 billion, something like that. Sorry about that. And next up is ulong, which goes from positive well, it's not a small number, but positive all the way to I think it's 1.8 trillion. If you look at signed, now, if you look at signed and unsigned, they hold the same amount of memory. Like I said when I started this video, unsigned just holds only positive numbers. So when you look at S bytes, for example, and bytes, if you add, S byte goes from negative 128 to positive 127, and it will give you 255, and this is of course S bytes. If you add it up together, however, if you choose bytes, okay, which is the maximum number of bytes. Bytes goes from 0 to 255, and if you add that, it goes to 255. And so think of it like a number line, think of the numbers like a number line, and you have 0 over here, so we've just moved the same numbers, just unsigned just means you're moving in this direction, but it's still the same amount of memory. I don't know if the same with the others, short and U short, the same amount of memory, just U short is only positive, and uint same as the same. The U's are just positive numbers only, but same amount of storage space. All right. Next up, let's talk about floating point types, which is this. So we're done with the integer. We're done with the integers. Let's not touch that. Let's not touch that. Anyway, um, everything we've talked about until now, integers have been whole numbers. So let's talk about floating point types, more commonly known as fractions, or decimals. There are three floating point types. We have the floats, we have the double, and we have the decimal. Let's start with floats. Floats are the smallest. Let's start with float, which is the smallest, of course. Floats are 32. Floats are 32 bits with a 7 digits. Oh, good lord. No, no, no. With a 7-digit precision. So we could say floats. And we say floats, fractions. And we say 0. Jesus. 0.123454678 9. Now you can denote floats with an F at the end. You see, if you don't do this, if you leave it like this, it's going to say literal of type double cannot be implicitly converted to type floats. Use an F suffix to create a literal of this type. So you have to put in the F at the end. And now it works. So you could say float fractions. And the computer will accept there we go. The compiler will accept that. Also, you can call actually, let's do this. You can call it single. Okay, you can call floats single. Although it will blur it out a little. And you say, but yeah, you can call it a single and it'll still work. But you should probably just call it a float. Next up, next on our list is the double. Doubles are 64-bit. 64-bit. And double is the most widely used floating point type. And just like integers, when it comes to whole number, double is the default type. So we say 4.5 like this. Okay, and so when I say default type, which it means that if we use the var keyword here, for example, and we hover over this, it will correctly assume, it will default to double, as you can see, because double is the default fraction type on .NET. The C# compiler will interpret it as a double, and also because it's a double, we don't have to denote the letter D. Okay, although it will, I think it will still work. Yeah, let's run it. Oh, see, it did work. But because it's the default, we don't have to put that there. Finally, let's talk about in the floating point type. So we've done floats, we've done double. Finally, decimals. Decimals are 128 bits with a 29 digit precision, usually reserved for financial and monetary calculation where the exact decimal is required. You can denote decimals with the letter M. I know some of you, those of you who are new to C# would have thought it would be letter D. Anyways, it's letter M. And here, we can get type, which is a, so let's see. And we say .NET run, and it'll tell us it's a system.decimal. See, decimal. It'll tell us it's actually a system.decimal. You typically don't want to use this unless it's important. You know, like, well, calculating money is very important. Also, maybe some huge physics calculations. So we're done talking about integers. We're done talking about floating point types. Let's talk about character types. Character, well, let's delete this. Let's talk about the third primitive type in C#, which is character types, commonly known as char. Okay? Char is a 16-bit Unicode character used in strings or low-level processing. So, for example, you can say char money, and you say $sign, you know, and that's the char. Always remember to use the single quotes to represent char. If I was to change this, so if I put money down here and I was to run it, I said .NET run. You see we have the $sign. If I change this to a, let's not ruin that. Let's actually just create if I turn this into a double quote, like this, and I saved it, you see it's not gonna work. If we hover over it, it says cannot implicitly convert type string to char. It will throw an error because double quotes are meant for strings. Okay? Keep that in mind. So, the compiler will assume you're trying to represent a string, and we'll talk about strings later. I think that's our next video. Also, let's take off this over here. Remember that it's just one character. So if I was to put in an extra like Y here, it's gonna also throw an error. Too many characters in character literal. It's only supposed to be just one character. Alright, so that's char. Remember, one single quotes and just one character for char. Let's go ahead and talk about what's left. Okay, the Boolean type. Finally, let's talk about the fourth, Boolean. Boolean type, also known as just bool, in C#, is a fundamental primitive type that represents logical values. It's one of the simplest and yet very important type in not just C#, of course, but programming as a whole. We'll talk more about that when I cover control flows and conditionals. Bools are either true or false, nothing else. So you say bool is active, you say true, or bool is complete, and you say false, nothing else. Okay, it is important to keep it in mind. C# doesn't allow implicit conversions between bool and other types like integers. You must explicitly compare values. So for example, here, let's just comment this out for now. Here's what I mean. So you say int x equals 5, and you say bool b equal x, is going to throw an error. Okay, and it says cannot implicitly convert type int to bool, exactly as I said. Now, however, if I said here's a much more correct way to use it. If I say bool b x, is greater than 0. Right, let's uncomment x. This is legal, and we can actually see this. Here, let's go ahead and clear the screen. .NET run, and we say it is in fact true. You see, it is true because x is 5 and x is greater than 0. If I say, let's say bool b equals x is equal to 5, and I say .NET run, it is true because x is literally equal to 5. If I say b equals x equals 4, for example, and I say .NET run, is going to say false, but this is still a valid expression. We're asking, it does bool equal to, is x directly literally equal to 4? And of course it's 5, so it's gonna say no. It's going to say false. But this is still a valid expression. So we've covered primitive types in C#, which are integer types, floating types, character types, and Boolean type. Character type, not types. And so we have under integer, we have the signed and unsigned. Well, signed, and under undersigned, we have s byte, short, int, and long. Under unsigned, we have byte, u short, u int, u long. Under the floating type, floating point types, which are of course fractions or decimals if you want to call them that, we have the float, double, and the decimal. Then we have the character type, which is just one character, also known as char. Used to represent just one character. Unicode, which means symbols and numbers. You can represent numbers, symbols, and any letter, as long as you use a single quote, and as long as it's just one character. And then finally the Boolean type, which is of course true or false. Thank you for watching this video. If you liked it, please hit the like, subscribe, hit the like button, subscribe, and leave a comment for future videos. Thank you.